This is actually more people than I was expecting, I guess in 5:45 on a Saturday evening. So it's actually good to be in Poland. And then until last night, I was very, very sure that driving in India was the hardest thing ever. But then I drove from Szczecin to Gdansk and had people overtaking me at like 200 kilometers per hour. So that was quite exciting. So it's good to be here. I just want to check that you guys can understand me in the back. Perfect. Okay, and also a show of hands, how many of you here are technical? How many of you here would prefer not to see any math on the slides? Okay, I don't have any math on my slides, but I can speak to it intelligently, but my goal today is to talk about robotics at Amazon and what we're doing to improve order fulfillment. I'm going to keep it fairly high level so that we can, and based on the questions, we can actually dive a little deeper to it. And I also have been given a challenge to bridge our time gap. We're 45 minutes late right now. I'm going to try to keep us only 15 minutes late, so wish me luck. Before we go any further, first thing I want to kind of clarify is what is a robot? We've heard a lot about AI and machine learning, and you almost hear a lot about bots or software robots. For me, this has been the best definition to distinguish what is a robot and what is just a computer or a program, right? The computers or software programs help us with information tasks. So your bots, assistants, Alexa, these are soft robots that are actually helping you automate information level tasks. Whereas to me, robots are mechanisms or things that actually help you with physical tasks. And that's going to be my consistent definition as we go through this presentation. And a little bit about myself. I've had a little background with robots. But before that, I've had kind of an interesting journey where I started off in India, did my high school in Singapore, kind of went to the US undergrad, had to go back to Singapore to work, and kind of did a few back and forths. I recently moved to London about a year ago, and about 3 weeks ago, I kind of moved to Luxembourg. But I haven't found an apartment yet, and I've been in Poland the last 3 days. I do travel a lot because that involves setting up every new robotic fulfillment center that we set up requires a lot of time to get it set up, to commission it, and make sure it actually works. And you guys will actually notice a lot of improvement if you order anything from Amazon.de or any of the Amazon websites. We've been building out a whole new network of robotic fulfillment centers, and I'll talk a little bit more about it. I think we can skip these. These are some of my previous work before I started at Kiva Systems. Kiva Systems is the predecessor to Amazon Robotics. We were the startup that got acquired in 2012. Pretty much the largest robotic acquisition ever. We were acquired for about $776 million, and it kind of changed the whole landscape on how successful is robotics as an industry tool. So we're actually based in Boston. And we currently have offices in London, Berlin, Luxembourg, and there'll be more coming up in Japan and Australia. And in terms of technology itself, we currently are pretty much the largest runner of cloud software for managing mobile robots. And I'll talk a little bit more about how we do it. Before we go into the details, how many of you have actually ordered something on Amazon.de or .com? Have you ever wondered, so I don't know, do you guys get Prime service here? Like, do you get your stuff in 2 days? Have you ever wondered how you can, is it 1 day? That's perfect. Luxembourg is 5 days. So it's a little sad. So have you ever wondered like what really happens behind the scenes? There's actually a lot of stuff that gets touched, right? So you're out here, you like something on the website, you buy it, we make sure your purchase experience is pretty seamless. And then we've got to figure out which building we're actually going to get this item from, right? And we don't store every single thing in one single building. We have a whole network of fulfillment centers. A fulfillment center, distribution center, warehouse, these are words that describe similar things. These are large buildings that store a lot of inventory that can actually be transformed into a customer order. We prefer to use the word fulfillment center because we're actually a lot leaner in what we actually store. And our whole purpose is to make sure we can quickly get the items you order into a box. And once we've gotten your order and we actually process that into a box, that's when it gets onto a truck, and we've got a pretty efficient delivery network, and then it gets to your house in as little as a day. There's also same-hour service these days if you're in London or Berlin. So this is our whole fulfillment network that we've been constantly trying to optimize. Amazon Robotics, we play a pivotal role inside, well, this should be 4 walls, but inside the circle of the fulfillment center. That is the place that we're actually trying to improve the cycle time, the cost, and the accuracy of how we process orders. And so what does a fulfillment center actually create? Right? We've got a lot of inventory that comes in. So you've got pallets and pallets of goods. It could be like a Harry Potter book, just pallets of them that come in. And out of the fulfillment center, we're effectively manufacturing boxes of orders. And then these orders are your orders that are trying to make it to your door. And a lot of the major steps inside the fulfillment center are basically 3 steps. We store a whole bunch of stuff. Then we have to sort it. I might have 1 million different types of items in a fulfillment center. From that, I'll have to pick out the red pen and the green pen that you ordered and get it into a box and get it to your address. So that sortation is where the real value creation takes place. And then we've got to move those boxes and move that inventory throughout. So there is a lot of moving, a lot of stuff that's stored, but the real magic happens in how quickly you can sort it. And that is where robotics really solved. Can I have the volume, please? So this video was filmed at one of our largest fulfillment centers in Tracy, California. I launched that building back in 2014. And interestingly, the town this building is in has the highest per capita of robots. There are about 3 Amazon Robotics buildings in that area. It's almost about 2 robots per person who lives in the town right now. And this building has about 4,000 robots in it. I'd also like you to keep a mental count of how many people are actually touching the teddy bear before it gets into a box or before it gets onto the truck. So we can have up to 1,000 to 1,500 robots running per floor, and they almost never collide just because of a very simple architecture we have where no 2 robots can exist in the same space. And the robots you actually see out there, that was from our previous generation called Atlas. They travel up to 1.7 meters per second, so they can cover pretty good distances very quickly. Even though robotics is still the largest value creator inside a fulfillment center, conveyance still plays a huge role in how we get packages out the door, and that's something we're looking to eliminate. Any guesses on how many people touched the teddy bear? 4? Any other numbers? 10? 2? All right, so there's a lot of touches that are actually not shown in the video. In reality, we have up to 9 people having to touch an item before it gets into a box. So that is still a lot of opportunity for us to improve and see how we make it for a lot more efficient. So you guys saw the robots, you saw the shelving units. There's a lot of other stuff that's happening behind the scenes that make our robotic system work. So at a high level, we have about 5 distinct components of our system. The first thing is, the most important thing are the drive units. Those are the robots, but we don't call them robots because we had a hard time selling them as a startup. Before we were called Kiva Systems, we were called Distrobot, Distribution Robotics. And the challenge we had, anytime you went to a customer and said, hey, we want to sell you robots for your fulfillment center, The challenge ended up being a lot of the people running and managing the fulfillment centers were usually folks who had barely graduated high school. They really weren't as tech savvy. They were good at managing people and resources, but not really good at managing technology. And the moment we said, we're going to bring you a robot, it kind of gave them this whole shock of this is going to be something very complex, and we won't be able to manage it. So that became really hard for our salespeople to go and actually get any kind of contracts closed. So then we made the decision of, let's try to get an analogy of what is similar to the robot that people are already used in a fulfillment center. A lot of these teams are already good at managing conveyor systems, and conveyor systems have motors that are called drive units. So the main motor that spins the conveyor belt is called the drive unit. So we said, our robots are very similar to the drive unit. So let's just call them drive units. We're not robots anymore. We changed the name to Kiva Systems, and that basically helped us with the customer adoption process and actually helped sell the story that here's a solution that your existing team can actually use and run your business. So for all the aspiring entrepreneurs there, I think that's something to be cognizant of as you're going down your path. Just be very sensitive how customers perceive your technology. So we have the drive units, and then we have the shelving units called pods. And it's not a one-to-one mapping. Most of the videos we have out there makes it seem like we have one robot per shelving unit. It's actually almost one robot to maybe 10 or 12 shelving units. So it's a very different ratio. And again, depending on the customer needs, we can actually change that. And again, we make custom shelving units based on the kind of products we're trying to sell. And then you actually have these chargers. The chargers allow drives to recharge themselves autonomously, so there's almost no human intervention. The robots use lithium-ion batteries. So they need about a 3-minute charge for every 90 minutes of work. So they're really tiny coffee breaks for them. And they tend to work pretty well 24/7. And then obviously the robots communicate over regular wireless. That's something we've optimized over time so that it works in any infrastructure. And one thing you don't see in the video are these barcode stickers. We call them fiducials. So these are actually stickered on the floor. So anytime we try to convert a building into a robotic building, we paste these barcodes on the floor as a grid. And that serves as a reference point for our robots to navigate. And we have the same barcodes underneath the shelving unit. So that tells your robot, and I'll show you what's in the robot there, but that tells your robot what shelf it's actually carrying. So that way it simplifies the whole problem of, do I know where I am, and do I know what I'm carrying? So we've simplified the problem and given ourselves good constraints to work under, and that's allowed us to be very, very robust. And finally, okay, not finally yet, but stations. That again is super important. Stations are basically the interface between the human associates and the robotic system. And that is where all the value creation takes place now. The robots have kind of taken away all the non-value add work, such as moving and storing, right? So the sortation part where a person actually has to interface with the product, that happens at the station. And a lot of thought goes into how do you build these stations so that a person can pick like 400 units per hour, right? So without a robotic system, a person maybe picks 100 units per hour. So we're basically making them 4 times more efficient. So we also want to make sure we're not introducing more defects. So there's a lot of thought that goes into how we design the station. And the actual software that runs behind the scenes, we've gone through a whole transformation. When we were acquired, all of our software was a monolithic code base that would run on on-premise servers. So anytime we had to make a software change, we had to take the building down for about 4 hours to make a change. In the last 3 years, we've been slowly pulling pieces of code out into services, and now we're almost 100% service-based, so we can make changes on the fly. So this allows us to actually run our fulfillment centers 24/7. And obviously, we host all of our stuff on AWS, but it will work on any cloud provider. All right, I think I've covered the big things here. Also, one interesting thing for you guys to note, anytime we say we're a robotics company, people assume the robots are the most complex part of our system. To give you guys a sense of scale, we have about 500 plus people working for Amazon Robotics. Of those is about 300 technical staff. Of the 300, we may have about 40 people who work on the actual robot and the hardware manufacturing. The remaining 260 people actually work on the software. The software is still where all the complexity is, and that's where all the real magic happens. So robotics today is still largely a software problem. And that's where all the developments that are taking place in machine learning, especially in the deep learning space, are actually helping us solve some of the harder problems. Okay, the robots itself, or the drive units. We've actually had 3 generations of them. When we were acquired, these were the robots that were in production, called the F drives. F because we started off with A, B, C, D. All of those failed. E was the first one we tried out, and then F became the first commercially successful one. And after acquisition, we started off with the Atlas drive units, which are the G drives, which were significantly faster and cheaper than the F. And then now we have the latest generation called Hercules, or the H drives, which are actually launching in Europe. We have a building in Stettin that's going live on Monday. So it's a pretty busy time for us. And to give you a sense of what we've been able to achieve with the 3 robots, I can't give you exact numbers, of course, but as a sense of scale, the very first robot, the F drive, costs about as much as a car, right? So it was a pretty expensive system for a customer to buy. We made the system about 40% cheaper in subsequent iterations, and they've still made the robots carry more payload and also stronger and faster. So a lot of this has come through innovation and just reducing system complexity, but at the same time also optimizing our supply chain so we can actually manufacture at scale and be efficient. So how does a robot actually work? The traction is fairly simple. It's got a couple of wheels and motors. But in terms of actual sensing, right, we spoke about the barcodes. It has a camera that's looking up and is looking for barcodes that are under the shelving units. It has a camera that's looking down, that's looking for barcodes on the floor. And finally, it has obstacle detection sensors that kind of scan for things that are falling on the floor, so we avoid them. Right? We don't like to crush anything that's fallen on the floor, and this provides us a safety mechanism. And in terms of the whole strategy itself, like I said, moving and storing inventory is a non-value add process, and that's the part the system takes care of. So all we're doing is we're bringing inventory to a person, and then the person does all the value-added work in the comfort of the station. Before robotics is introduced to a building, human associates would walk. They would usually walk about 10 to 15 kilometers a day, just moving between shelves. Right? So there's a lot of walking, a lot of moving, and a lot of non-value-added work. So here we're actually helping them become significantly more efficient. And also, we've also significantly improved their quality of life because now they have a sense of, hey, here's my so-called desk, because they're at a station that they're assigned to them. They have a sense of ownership. So the associate experience has also increased significantly. I think we can skip this part. Scale. You heard the word scale a few times today. I think scale is pretty much like the middle name for Amazon. Right? Everything we do has to scale just because of how fast our business is growing and the challenges that come with it. The beauty of the robotic system is that it allows you to scale very quickly. Unlike existing material handling systems, which are usually conveyance systems, these systems are bolted down to the ground, and if you ever have to, if your business volume increases by 10 or 20%, that usually will render your conveyance system useless because it's very hard to improve or increase the capacity of the system. On the robotics side, we're just able to add additional robots as and when we need it and sequentially expand the capacity of the system. And in terms of the scale the software has to handle, right, we need to be able to handle thousands of associates working on the system, right, multiple thousands of robots, up to millions of different products, right? So our software services have to be able to process these transactions at scale very, very, very quickly. And to give you a sense of what the scale actually looks like, the usual story at Amazon is every time we put a number on a slide, the number is already old. This slide was accurate as of 3 weeks ago. We just added 4 buildings in the last 3 weeks. So we have more than 30 fulfillment centers in the world. And these are massive buildings, right? These buildings are about half a mile long. In kilometers, that's about, someone help me? It's about 800 meters long, and usually gets about 1 million square foot of cube, multiple levels of robotic storage platforms, 4,000 to 5,000 robots in there, right? 4,000 to 5,000 people. It's a massive operation, and we've got lots of them around the world. And in terms of robots, we have more than 80,000 robots in the world right now. We are the largest operator of mobile robots in the world. We have more robots than the US military. And this number continues to almost increase at a 30-40% rate year over year. And we always, you heard the thing that Amazon is metrics driven. We are all data geeks, so we like to measure everything that we can. So one number we're always curious about is, hey, we've stopped people from walking 10, 15 kilometers a day. So how much are the robots actually moving? So last year we covered about 36 round trips to the moon. And that's a pretty big number. And I was thinking about how much that actually translates to. That actually is 1.2 astronomical units. An astronomical unit is the distance between the Earth and the Sun. So this is a big milestone for us, because when I first started tracking this number, I was using the number of round trips around the world as a measure, and it quickly became a much, much bigger number to tackle. So scale is important, right? Every single move we make is a transaction that has to execute flawlessly. So there's a lot of software work that goes on behind the scenes. And to do that, we really had to leverage a move to services in the cloud so we could actually get access to scale easily, and also rethink how we do our software. Right? Like, how do we move away from having a full state-based system, which wouldn't scale as easily, to something that's stateless, but simple, just having simple RESTful calls, a stateless system, but still maintain state, because the system is stateful. We need to know where the robots are all the time. We need to know where products are all the time. But how could we decouple that system so that you could still be stateless and you can still scale and simplify interactions between different components, but still make sure that you're making no mistakes? And we don't have robots crashing into each other. So it's a lot of good robustness in the system. And that comes from a very simple philosophy that our founder, Mick Mounts, kind of put into us, which was always start simple, and then you go optimal. Right? It's very easy to think about what is the optimal solution first, and then end up building something that's incredibly complex and hard to scale. For us, it's always been, do the simple stuff first. It might look stupid, but do the simple stuff first and do it right. And then you'll figure out how to optimize it. And that way, algorithms can always be optimized, and we always get improvements year over year. But we get the right thing working quickly, allows us to move fast, and allows us to troubleshoot things really quickly. But then we can always come back and optimize it after the fact. And the other thing too, when I said the system is stateless, or at least our architecture is stateless, but we also need to capture the change in state. Right? Every time a robot moves, the state has changed. So there's some really interesting algorithms behind the scenes that make this happen. Okay, for sake of time, I'll skip this, but we can talk about this if you guys have questions on how it really works. But an important takeaway is here. What robotics has given us at Amazon is effectively an API to the physical world. AWS and all the other services have given us APIs to informational tasks. Robotics basically has given us an API to physical tasks. So now we can do some really cool things on, if I know Harry Potter is going to be on sale tomorrow, we can dynamically restart all of our inventory and fulfillment centers and say, bring all the Harry Potter books closest to the pickers and store them closer to the stations, because we know we're going to need this for the next couple of hours, so we optimize every single transaction. So this kind of restocking and resorting in a fulfillment center is almost unheard of in a manual building or a manual operation. And we're just barely scratched the surface. We've been spending so much time just tackling the problem of scale that I hope we get time next year to just take a step back and say, okay, we've scaled. Let's go back and start optimizing all these things that we can actually get a lot more headroom for performance on. Okay, so you guys saw our mobile robots, right? These have been very similar to what we've been doing for almost the last 8 to 10 years, at least as Kiva, and then the last 5 years as Amazon. What is next? I really can't tell you what we're working on in-house, but I can give you clues, because we've dropped some pretty big ones publicly. We fund a competition called, it used to be called Amazon Picking Challenge, and now it's just called Amazon Robotics Challenge. And the whole premise of this is we're trying to crowdsource ideas on solving some of the hardest problems we have in robotics today, which is autonomous picking and grasping. Like, how do you train a robotic arm to autonomously pick any kind of object and place it in a different location? And a lot of people, anytime I tell them, hey, picking is a hard challenge, the usual response I get is, but we've had robot and robotic arms like in the industry since the 1980s. It's a true statement. But all those arms since the 1980s that all exist in manufacturing do repetitive tasks really well. They're pre-programmed to execute exact maneuvers, and they're really good at repeating that task. They have high repetition, but they have zero tolerance for any kind of anomaly. In our system, what we need to deal with is the whole complexity of how do I pick everything from, I don't know what that is. say, a book all the way to a soft toy that might be hidden somewhere in there. Like, how do I have an arm that does all of it? And be able to recognize things that are not clearly visible, because sometimes you have products that overlap with each other. And there's other additional layers of complexity that come with it. And that is significantly different from doing something really slowly. So this is a PR2 robot by Willow Garage, which does some exceptional tasks. It can actually fold towels. It can play billiards. It has some really incredible arms. But unfortunately, it does it exceptionally slowly. And then you have robotic arms or picking systems that can pick the same item really, really, really quickly, because it can just like blindly pick anything it wants to. Right? Same thing with screws or fruit and so on. But in our case, we've got to be able to pick with stuff from inside a bin, be able to see behind or at least guess where an object really is, how it's oriented, how do you pick it without dropping it, and also how do you place it in a way so that you can actually pick it out again. Okay. Sorry, I had a video in there. It's going to come back a little later. But autonomous picking, grasping is an incredibly hard challenge. That is something, if any of you out there have a solution, come talk to us. I think that's the best way I can put it. And also, zooming out to the big picture, right? We spoke about what happens inside the fulfillment center and the challenges we have out there. But obviously, we still have, our business is much bigger than just that when it relates to order fulfillment. So I will just let you guess on what else we would be working on to help improve the customer experience. And obviously, these are just my opinions, and you will see what happens in reality pretty soon. And I can take questions while this is playing in the back, but these are videos from the Amazon Picking Challenge, and you guys can see how slow the solutions actually are out today. But while that's happening, any questions, feel free to shoot them.
Okay, anyone? Questions?
Come on, guys, we have 3 minutes.
Are the robots autonomous or centrally steered?
That's a very good question. So the robots are locally autonomous?
And follow up, do deadlocks happen? Deadlocks, like one robot blocking another and another?
It's a very good question. So the robots are locally autonomous, but globally they're coordinated. So every robot knows its own control system can help it adjust to any anomalies it finds on the floor. If a barcode is off location, if it senses an obstacle in front of it, if it loses connection to the wireless, it has enough local autonomous behaviors to recover from those failures. Globally, we use coordination software that makes sure that no two robots will ever be in the same location. We never end up. We first started off doing stupid things where we have two robots just butting with each other, right? Like they lock themselves out. We've obviously gotten smarter over time. But a lot of this stuff is done globally and centrally because it's a lot easier to solve that problem when you have global information than trying to do it locally. So we use a hybrid model to make sure we're able to keep thousands of robots running simultaneously with no issues.
Any other questions? It's getting late. Thank you, Vikas. Thank you very much.
Thanks, everyone.